could look at your MT7 LT4 seminar. Before we begin, do the 5 questions to get your brain warmed up for the prior knowledge you're going to be doing on this lesson. And we are going to be looking at rectangles today. When we look at a rectangle, remember a rectangle is a parallelogram. So everything we know about a parallelogram is true about a rectangle. We know that the opposite sides are congruent. We know the opposite sides are parallel. We know the opposite angles are equal. Well, in a rectangle, all the angles are 90, but so that kind of moots that point. And we know that the diagonals bisect each other. And in this case, we know something else. In a rectangle, the diagonals are equal. And since I know they bisect each other, I know all these parts are the same. So notice what happens here. I get a whole bunch of isosceles triangles. The one thing to remember, they don't cut that vertex in half. You can see even by my drawing on here that they do not bisect the vertex angle. So angle A is not 45 and 45. It might be 30 and 60. It doesn't have to be bisected. It could be any pair, but they still have to add to 90. That part is going to be true. So if we take a look at our first example here, the coach is making a basketball team run a new drill along the diagonal of the court as shown. We know B to C is 94, so I'll put in 94 there. And we know F to C is 106.5. And then we want to find D to G. That's what I'm looking for, is D to G here. And you're saying, well, how in the world do I find that? Well, remember, the diagonals are equal. So what I'm going to do, in angle B is a right angle, I've got a right triangle here. My hypotenuse, FC, squared, equals 94 squared plus 106.5 squared. So in other words, let's do this. Let's use our calculator to take 94 squared, using kind of overkill with the Desmos calculator here. Probably don't need a graphing calculator to do this, but we're going to go 96 squared plus, if I remember right, it's 106.5, 94 squared plus 106.5 squared. So 94 squared plus 106.5 squared. So notice we get about 20,178. I'm going to keep that number in the calculator, but I'm just going to say 20,178 right here. So to find F to C, we'll take the square root of that. So in this one, we're going to say the square root of 20,178.25. And you get about 142, don't you? So F to C is around 142. If we want to take it a little bit further than 142, we'll say, yeah, about 142.1. Now that's F to C. Well, that's also B to D because the diagonals are equal. And I know D to G is half of that. So if I take 142.1 and I divide that by 2, we get about 71, don't we? So we know D to G is about 71 feet. So if they're running from D to G, they're running 71 feet. Now let's take a look at our next one. We know this is a rectangle again. We know angle B to A to C is 3x plus 5. I think I'm going to blow that up so I can write it in here. So this is 3x plus 5. We also know that angle ACB is 5x minus 1. So A to C to B is 5x minus 1. And since it's a rectangle, I know that this is the right angle. So I know angle A and angle C, they're going to add to 180. Not 180, add to 90. Because there's 180 degrees in a triangle, one of them's 90. So we're going to say 3x plus 3. I think I wrote in 5 there. That's supposed to be a 3. Plus 5x minus 1. That's going to equal to 90. And we're just going to solve for x. So we get 8x plus 2 equals 90. Solve that equation, minus 2 from both sides. 8x equals 88. Divide by 8. X is going to be 11. And that is what we're looking for. We're looking for x there. And then we have the converse theorem. But the one thing about the converse theorem is pay attention to the if part. It's got to be a parallelogram first. So if the diagonals of a parallelogram are equal, then we know that is going to be a rectangle. It's not just any quadrilateral. It's got to be a parallelogram first. We have to show it's a parallelogram first or told it's a parallelogram. Then we can do it.